Hello viewers and students, you are welcome to this YouTube channel. Kindly subscribe to this channel for more updates. Share and like it. Today we are looking at stoichiometric calculations, and I'll be teaching you how to solve questions involving stoichiometric calculation using mass-to-mass relationship. We are going to consider how to solve questions on stoichiometric calculations by using mass-to-mass relationship by considering the following examples. Example 1. What mass of calcium oxide, CaO, will be produced by heating 20.0 gram of calcium triacylcarbonate 4 CaCO3 to a constant mass according to the equation of reaction below. The equation is stated below. In that reaction, calcium triacylcarbonate 4 is the reactant, while calcium oxide is the product. So we are calculating the mass of the calcium oxide, which is the product, that will be produced if 20.0 gram of calcium triacylcarbonate 4 is heated to a constant mass. We are going to start from the equation. In the equation, we have 1 mole of the calcium triacylcarbonate 4 heated to produce 1 mole of calcium oxide. You start from the equation. In the balanced equation, the numerical coefficient represents the mole of the substances. So you have 1 mole of calcium triacylcarbonate 4 heated to produce 1 mole of calcium oxide. So you start from there. Now, the first thing we are going to do is we calculate the molar mass of each. Calculate the molar mass of each substance as follows. We have been given the atomic masses in the question. So let's calculate the molar mass of Let's calculate the molar mass of each of them. Molar mass of calcium oxide is calculated as follows. 1 times 40. The number of atoms is 1. You multiply the number of atoms of each element by the atomic mass given. 1 times 40 plus 1 times 16 gram per mole. That's the unit of molar mass. You have 40 plus 16 gram per mole, and that gives us 56.0 gram per mole. That's for the calcium oxide. The same way, calculate the molar mass of calcium triacylcarbonate 4. Using the atomic masses given, you have 1 times 40 plus 1 times 12 plus 3 times 16 gram per mole. You must consider the number of atoms of the component element and multiply by the atomic mass of the element given. So you have 40 plus 12 plus 48 equals to, add everything up, you have 100 gram per mole. That's the first thing you do. Calculate the molar mass of each substance involved. The next thing that you do is to relate them mass to mass. You relate them mass to mass together. That is, we find the mass of the calcium oxide from the mass of the calcium triazocarbonate 4 given in the reaction. So step 2. Step 2, using, like I told you that we are using this method, mass to mass. From the question, we are asked to find the mass of calcium oxide from the mass of calcium triazocarbonate 4 reacting. So we are relating them mass to mass together. So using mass to mass relationship. Mass to mass relationship as follows. So we are going to convert from the question, from the first statement above here, you have 1 mole of calcium triazocarbonate 4 producing 1 mole of calcium oxide. So we are going to convert each mole to the respective mass in gram by multiplying by the molar mass as follows. So you have 1 mole multiplied by 100 gram per mole of the calcium triazocarbonate 4. To produce, you do the same here, convert the mole to mass by multiplying the mole according to the equation by the molar mass, 56 gram per mole of the calcium oxide. So from the equation, the mole will delete each other like that. This will delete, and now you are left with this 1 times 100. That is 1 times 100 gram of calcium triazocarbonate 4 to produce 1 times 56 gram of calcium oxide. So we have 100 gram of calcium triazocarbonate 4 producing 56 gram of calcium oxide. We have converted both of them now to their respective mass in gram. So the 1 mole of calcium triazocarbonate 4 is equal to 100 gram by multiplying the 1 mole by the molar mass. When you are converting mole to molar mass, to mass in gram, you multiply the mole given by the molar mass of the substance. So 1 mole of calcium triazocarbonate 4 is equal to 100 gram of calcium triazocarbonate 4. And the same 1 mole of calcium oxide is equal to 56 gram of the calcium oxide. So that represents what we have in the equation. So the next thing that you do is to go to the mass of the calcium triazocarbonate 4, put into reaction. So if 1 mole, which is 100 gram of calcium triazocarbonate 4, is completely decomposed to produce 1 mole of calcium oxide, which is equal to 56 gram by our conversion. Therefore, 1 gram of the calcium triazocarbonate 4 by proportion will give 56 over 100 gram of calcium oxide and 20 gram, which is the actual mass of the calcium triazocarbonate 4 put into reaction, we produce 56 over 100 multiplied by 20 gram of calcium oxide. By your multiplication, you have this, and when you divide 56 by 5, you have 11.2 gram of calcium oxide. That is 20 gram, 20.0 gram of calcium triazocarbonate 4 will decompose on heating, to produce 11.2 gram of calcium oxide. So this is how to calculate the mass of the calcium oxide. If 20.0 gram of calcium triazocarbonate 4 is completely heated to a constant mass. So, like I said, start from the equation. From the equation, relate them mole to mole. 1 mole of calcium triazocarbonate 4 heated will produce 1 mole of calcium oxide. Don't forget, those are the two substances that your attention is based on. 1 mole of calcium triazocarbonate 4 heated will produce 1 mole of calcium oxide. Then we calculated the molar mass of each. The molar mass of calcium oxide is calculated as 56 gram per mole, while the molar mass of calcium triazocarbonate 4 is calculated to be 100 gram per mole. The next thing that you do is to multiply the mole by the molar mass of each in order to convert that mole to the mass in gram, so that we now have mass against mass relationship. Calculating the mass of 1, which is calcium oxide, from the mass of the calcium triazocarbonate 4, put into reaction. So we have 20 gram of calcium triazocarbonate 4 decompose on heating to produce 11.2 gram of calcium oxide. That's how to solve that. Let's go to the second example. Example 2. We are given that ion react with dilute H2SO4 according to the following equation. The equation is given. The equation is a balanced equation so that we can relate the two substances mole to mole and later convert to mass relationship. From the question, we have to calculate the mass of the FeSO4 that will be produced if 1.12 gram of ion reacts completely. The first thing that you do is calculate the molar mass of each. What are the two substances that we are concerned about? We are concerned about ion and FeSO4. Ion is the one reacting with the acid to produce FeSO4. Those are the two substances that our attention is based on. So calculate the molar mass of each. We calculate the molar mass of each. The molar mass of ion, being a metal, is going to be 1 multiplied by the atomic mass, gram per mole, and that gives us 56.0 gram per mole. That's for the ion, the molar mass of ion. We also calculate the molar mass of FeSO4, which is the products, and that is calculated as follows. We have 1 atom of ion, 1 times 56, plus we have 1 atom of sulfur in the formula, 1 times 32, plus we have 4 atoms of oxygen, 4 times 16 gram per mole. We add everything up. The first bracket we have 56, the second bracket will give us 32, the third one will give us 64. Add everything up, we have 152 gram per mole as the molar mass of the product, FeSO4. The next thing that you do is to relate them mass to mass. From the equation, we have 1 mole of iron reacting to produce 1 mole of FeSO4 by relating them together. Then, using mass to mass relationship, don't forget that we are calculating the mass of FeSO4 that will be produced if the given mass of iron, which is 1.12 gram of iron, is put into reaction. We are calculating the mass of FeSO4 in grams that will be produced if 1.12 gram of iron reacts completely. So we are using mass to mass relationship. So we are going to convert the mole of each to the mass in gram by multiplying the mole by the molar mass of the substance. So this is going to give us the mass in gram of that substance reacting. The same way, you multiply 1 mole of FeSO4 by the molar mass we have calculated above, which is 152 gram per mole. So let's cancel the mole. They delete each other as follows. This delete this. So therefore we have 1 times 56 gram of iron reacting to produce 152 gram of FeSO4. So we now have 56 gram of iron, which is the 1 mole, will react to give 152 gram of FeSO4. So this is what you have according to the equation. The 1 mole of iron in the equation is equal to the 56 gram. Don't forget how we got the 56 gram. We multiply the mole by the molar mass. That's how to convert the amount in mole to the mass in gram of a substance. You multiply the amount in mole by the molar mass. So according to the equation, we have 1 mole of iron reacting with 1 mole of the acid to produce 1 mole of FeSO4 and 1 mole of hydrogen gas. But we are concentrating on only 2 out of them, which are iron and FeSO4. So they are related 1 to 1 to each other. So we have 56 gram of iron producing 152 gram of FeSO4. So 1 gram of iron will produce 152 divided by 56. If 56 gram of iron will produce 152 gram of FeSO4, then 1 gram of Fe will produce 152 divided by 56 gram of FeSO4 by proportion. Therefore, what is the mass of iron reacting? According to the question, we're given that 1.12 gram of iron reacts completely to produce FeSO4. So what is the mass of FeSO4 that will be produced? So if 56 gram of iron will produce 152 gram of FeSO4, And 1 gram of Fe will produce 152 divided by 56 gram of FeSO4. Therefore, 1.12 gram of iron will produce 152 divided by 56 multiplied by 1.12 gram of FeSO4. So let's calculate that. So when you divide that, you have 3.04 gram of FeSO4. That is the mass of FeSO4 that we produce. So it means 1.12 gram of iron will react completely to produce 3.04 gram of the product, which is FeSO4. So that is how to get that. Don't forget, we are looking at the calculation on stoichiometry using mass to mass relationship. How to calculate the mass of one substance from the mass of another given in the reaction. How to calculate the mass in gram of a substance from the mass of another that is involved in the reaction. Mass to mass relationship. So these are the examples we have been able to consider on that. And don't forget, subscribe to this channel, share it, and like it. We'll see in the next class. Thank you.